Hi there, welcome to the Privacy and Security YouTube live session. This is the last session of our series for PhD students. I'm Maggie Akers. I'm on the University Programs team, and this is Vijay De Silva. He's going to be our speaker today, and I'll let him introduce himself in just a few minutes. Before we get started, I want to point out the chat box on the right-hand side of your screen. It's moderated by a few of my wonderful colleagues who are more than happy to answer any questions you might have throughout the session, and we'll save a few questions for Vijay at the end. I'd also like to highlight the opportunities we have for PhD students at Google. We have a software engineering internship for PhD students, and the application closes January 31st. If you haven't already applied, be sure to do so by the end of the month. We also have a full-time software engineering role for PhD students. That application is always open, but we do recommend that you apply sooner rather than later. We'll talk more about opportunities and the application process at Google later on in the session, but for now, I'm so excited to hand it over to Vijay, who's going to talk more about privacy and security at Google.
Thanks, Maggie, and thanks everybody who's tuned in. I'm a software engineer in the privacy and security team here, and I'll use our time today to tell you a little bit about the journey that took me via research to being a member of the privacy and security group here in Google. And one of the major surprises for me was that there was a lot of outlet and opportunities to use the kind of training and skills I had acquired in my PhD. And I'll tell you a little bit about that in this talk. And towards the end, we'll talk about the application process. So I started out as an undergrad in IIT Bombay in India, where I learned and did projects in circuit design. And later, I was a master's student at the University of Zurich in Switzerland, where I started learning about logic. And I got really interested and decided to pursue the study of logic more in my PhD, which was largely theoretical. I should say entirely theoretical, actually. And towards the end, I was curious, first, to know, does the kind of work I was doing have applications? And secondly, also, will I ever be able to find a job doing this kind of thing? Which is why I got a postdoc at the University of California, Berkeley. And throughout this process, I assumed that I would be an academic long-term because I really enjoyed things like reading and writing papers, teaching, interacting with colleagues who were doing the same thing but also had a broad range of interests. But the reason I started questioning the assumption of being an academic was what I perceived as negativity in the review process and uncertainty about both where I would find a job and also how long I would have that job, as well as just realizing that there were demands on my time as an academic which I had not been aware of, and maybe wasn't entirely how I wanted to spend my time if I could choose. If you read articles and listen to talks on this topic, there are a few more things that people will talk about, like freedom and the ability to do long-term research. And I encourage you to read articles and talks given by other people, such as the ones on this slide, and form your own opinions. But what I will say is that there are a lot of issues where there isn't a simple, clear-cut dichotomy between having a job in a university and having a job in a company like Google. There are differences in priorities, but my experience is that there aren't activities that are fundamentally in opposition. And I put a lot of that on the slide, and hopefully you all can come back and ask me about this at the end. But first, let me tell you a little bit about security and privacy work in Google. This is not a comprehensive overview by any means. It's just meant to give you a few snapshots here and there. And I encourage you to go and read about this on our websites. So what is security and privacy? Rather than explain from definitions, I think we all have an intuitive idea what it means for our data to be secure or our information to be private when it comes to something sensitive like conducting a financial transaction or buying things online. But security is involved in nearly every interaction you will have with a computing device. Say you go to a cafe with a friend and you log on to the wireless network there. Then the natural question is, can the person who owns that wireless network find out which websites you're visiting? And suppose the portal for for the Cafe Wireless gives you helpful links to where you can check your email. Is it safe to actually click on one of those links? Now, it might say something like gmail.com, but that O might be an English O, or it might be something that looks like an English O but is Omicron in the Greek alphabet. So you might click on it and go there and see something that looks like the Gmail page, but it might trick you into getting your password. And this is an example of what is called a phishing attack, right? And now those are things that target everybody, but there are also somewhat more dramatic scenarios. Suppose your phone is stolen and then recovered, or one of the people in that earlier picture, suppose they're a vice president of engineering at a company like Google. Then a major concern is, did the person who stole the phone use it to access sensitive data or information about Google? Did they use that to log on to our networks? And the way we would determine this is we have forensic investigators who would go and look at this device and try to reverse engineer what happened. And what I have found fascinating is that the same kind of techniques and knowledge exist among forensic investigators in, say, law enforcement, and they also use and share similar tools and techniques. So I'll give you a snapshot of the projects we will be working on. You can find descriptions of these and more at research.google.com, and specifically there's a section of that site that talks about Google's security, privacy, and abuse research. Now, one of the long-running projects that we have is called safe browsing. So to go back to the example of clicking on a link that tricks you to get your password, that's a phishing site. There are other sites that may try, when you click on them, to download a package to your machine. And they might also try to install software on your machine that gives an attacker access to your machine so that they can either steal your machine or use your computing resources to perform attacks elsewhere. So there is a big concern about protecting users off the web from malware and phishing sites. And Google, since at least 2009, has an effort called Safe Browsing that studies and categorizes these, as well as documents them in an API. So if you ever access the web using Google's Chrome or Firefox or Safari, you have used the results of the Safe Browsing team's research, which is also reported in their transparency report. So if you look at the graph on the screen, this one, you will see that there is a red and a blue line, and it's not entirely simple. We would like to believe that our efforts have led to a decrease in malware over time. But another aspect of security research is that attackers are human beings and are also motivated by many things. So every time we come up with a defense, they come up with another way around it, and continuous research and engineering is required to deal with it. And our teams have also written papers about this that study not just the attacks, but also the economy that funds and fuels this. And an understanding of the economy is behind what are called rewards programs at Google. So suppose you start at one of Google's websites and you are able to reach a situation where you can run your own code without any authorization on Google's servers. I believe, and you will have to check our websites for the details, that Google will pay you up to $20,000 as a reward for finding such an exploit. So there's a wide range of exploits, and Google supports vulnerability researchers and recognizes that they want to be rewarded monetarily for this kind of work. And since 2010, over $6 million has been paid for such work. And in fact, in 2015 alone, over $2 million was paid for as vulnerability rewards. Okay? So Google also has programs to support researchers while they do this kind of work, not just after they've found the results. So that is one kind of work that we engage in. We also have our own teams of researchers that are continuously looking for vulnerabilities and also making it easier, we hope, for other developers to secure their own software. So one example is cryptographic software. Cryptography and encryption algorithms might be developed with various mathematical assumptions in mind. And researchers over time have learned and discovered and published that even if an algorithm is proved to have certain guarantees under some assumptions, when you implement them, there might be details because of the programming language, the compiler and its optimizations, and the platform on which the code runs that violate those assumptions. And this then introduces a vulnerability in that software. So in December last year, Google released Project Witchproof, whose spelling you can see on the slide, which documented a lot of these known implementation related bugs and found over 40 security related bugs. And I encourage you to go and look at the code on GitHub, but also the documentation where you'll see that in order to write that tool, people had to really read and understand academic research papers, but also have an intimate knowledge of the engineering platforms and the standard libraries that were used to implement them. So those might seem like pretty low-level security work. I'd like to emphasize that security is something that occurs at every level of the technology stack. So to go to the networking level, a continuous concern for people is what is called a distributed denial of service attack. These are often always in progress, where attackers get control of many different machines and generate traffic that targets one or a group of servers. And the idea is to overwhelm those servers and take them down. And on the slide, you will see a visualization of denial of service, distributed denial of service traffic targeting Brazil during the Summer Olympics of 2016. And this was work that was done in collaboration between a team called Jigsaw in Google, concerned with security, and a big picture team in Google, and a team called Big Picture in Google, which consists of experts, many with PhDs in data visualization. And this also speaks to a concern that I had before coming here as an academic, which is I had very broad interests and I wanted to learn many things like data visualization. But I thought as an academic, I would not have the time to specialize and contribute to such a field. But here I've found that I'm able to find such teams and engage with them, and it gives me insight into their research. So security and privacy are not the only areas in Google where research happens. I'll take a few minutes to highlight a couple of other activities within Google. Another concern I had before I joined here was that I spent a lot of my time as an academic, first as a researcher in circuit design and then in logic, and I wondered, will I have to throw my brain away when I go to Google? Will all that knowledge and years of training be useless? And what's been very rewarding for me to see is that there are researchers in all those areas. They continue to do research, and I can go to their talks and read their papers and stay abreast of research in those areas. One example being this study of programmers' errors done by some of our engineers in 2014, where they looked at 26 million bills that Google engineers had made over a period of 6 months. And they classified, they analyzed, they studied all the errors, how long it took to fix them, and then they published a paper about this. They also used the results of that analysis to develop tools that would then improve the lives of Google developers internally. And this is something I found really cool, that not only did they do this kind of study, but they used it to influence our engineering. A fairly different type of research project, which is almost a meta science project, is the NIPS consistency experiment. In, I believe, 2014, Corina Cortez, who is a researcher in Google, and Neil Lawrence, who is at the University of Sheffield, were co-chairs of a conference called NIPS, which is one of the leading venues in machine learning and artificial intelligence research. And it's a really big venue. They get a very large number of submissions. So they had 2 program committees. And the co-chairs conducted what is called the NIPS consistency experiment. They took 10% of the papers and they gave them to both committees. And then they analyzed and compared whether the committees agreed in their evaluation of the paper. And I encourage you to go and read more about this. But what was amazing to me is first that this research was done, which to me is very deep fundamental research because it is about the science of how we produce and expand knowledge. And secondly, it was very comforting for me to see that one could be in a place like Google and still engage in such activities. So going further away from the traditional academic and publishing scenario, a lot of people in Google have research backgrounds, so they appreciate that in order to do research, even in other places, you need access to good data and tools to look at and analyze that data. So there has been a lot of activity in collecting, curating, and releasing data sets. You can find a lot of different data sets on our research website. This is an example of a visualization taken from a tool called Embedding Projector, using data from something called Word2Vec, which turns words into vectors in Euclidean space so that closely related words appear close together. And both the data has been used by many different teams. The tool is more recent, but I encourage you to check it out. It looks pretty cool. Um, so those are all somewhat technical. I'm not going to speak very much about non-technical things, but in Google, if you are interested in, say, social and policy related issues and want to use your technical background, I was surprised to find that there were opportunities for that as well. And one example is the Wassenaar Agreement, which is an export control association. The Wassenaar Arrangement, which is the name of an export control association that the United States is a member of. I believe this arrangement has been in place since 1996, but they released some changes in, I think, around somewhere between 2013 and 2015. And these changes were going to cover software and export of software and what they called intrusion software. And there was a lot of confusion and head scratching among security researchers and the open source community, as well as companies. And within Google, security experts sat at a table with policy experts, legal experts, and they studied this. They wrote about it, they decided what Google's position was, and communicated that to the general public. And so this is also the type of work that can be done here using our research and exposition skills that you might acquire during a PhD. So apart from directly doing or communicating research, there are several avenues that I was pleasantly surprised to learn for using research skills. And one of the main ones here is Google itself. So when I first joined Google, I was a very junior engineer, and there were several managers and vice presidents above me, all the way up to Larry Page. And what blew me away was that every single one of them had a PhD. This is not to say that every member of senior leadership in Google has a PhD or even needs a PhD, but I did not expect that people with technical and often computer science PhDs would be so well represented at that level of leadership. And their background and their skills have been fundamental in determining Google's engineering culture as well as general culture. So all these people have participated in defining what, say, code review looks like in Google, but also what our hiring practices and policies should look like. And that has created an environment where I found it very easy and natural to settle in as an engineer and, set a kind of tone for work that made it very conducive to the kind of skills I have. So apart from doing day-to-day Google work, if you have a PhD, if you're involved in academic activities, you can also continue those activities here. I was a fairly junior academic. I did paper reviews before coming here. I have continued to do paper reviews here, and many Googlers serve on program committees, on editorial boards, and that has been a source for me to receive papers to review. People serve on program committees. I mentioned Corina Cortez as one example as chair of the NIPS conference. There are several other people who have been chairs of conferences. I know more senior Googlers who have been editors for journals or even written books. This is not to say people come here and spend all their time on such activities. It usually requires agreement from a manager and some amount of time spent doing things that Google really cares about, but all of this is possible. So one thing I really did not expect on coming to Google is that I would be able to continue to teach or interact with students, because that was something I really enjoyed, and I had to reconcile to myself that I will give this up. And I was pleasantly surprised to first discover that Google has an internal education infrastructure where people conduct courses and others can attend them, and it's really useful for learning about all the systems that exist here, but also simple things like just how to program in C++ and so on, or rather let's say, Google grade C++ programming. And I was also allowed to teach at summer schools externally, not organized by Google. So this was fine. I was able to get permission from my manager for that. I know of other Googlers who have guest lectured at universities and some who are even adjunct faculty. So all of that is possible. There are both faculty visit programs and mentorship programs that allow people to supervise students. I am a Google industry mentor for a PhD student who is funded by Google. I also have another student who's not funded by Google, but that's also fine to continue doing. And yeah, I was amazed that that is all consistent with being here and doing my main engineering work. So with all that said, there's also what I learned is at Google is to broaden my conception of what constitutes research and contribution to the community. Google invests very heavily in open source related work, and there are many different projects there. And I have been encouraged to think of doing open source work also as a way of giving to the community and participating in research. So with all that said, as Maggie mentioned right in the beginning, I hope some of you will consider applying. Please go to, so one is there are software engineer positions that PhD graduates can apply to. There is no deadline. You can do this any time of year. There's also a PhD internship. I mentioned earlier that my PhD was largely theoretical. I did only research internships. I really wish now that I had interned at a place like Google, because that would have just given me more perspective into the kind of options that I have. And from that point alone, I would encourage you to do that. So applying to Google, they tell me, I talk to the hiring team, is as easy as 1, 2, 3. So go to google.com/students and you can look and search for the best role for you. All you have to do is upload your resume and submit. So with that said, I would encourage you to also prepare. I was very worried when I applied because I did almost no coding in my PhD. So I consulted Google's Guide to Technical Development, which you can find online. There are several texts such as Cracking the Coding Interview, the Algorithm Design Manual, Programming Interviews Exposed, and I think this one called 300 Problems or so. I did a lot of programming. I learned to enjoy programming. It was very useful, and there are many ways to practice. So with that said, I hope you'll consider us, and good luck.
Great, and before we go, we do have a couple of questions from the chat. So our first question is, in what ways are circuit design and logic relevant to Google?
Okay, so Google makes its own hardware. I think sometime last year they announced a tensor processing unit, and they have had various other kinds of hardware projects in the past at different scales. They may not always have, released consumer devices related to hardware, but there's always been some, by always I mean there is hardware work going on. So that requires circuit design knowledge, and there are teams doing that. And when you reason about circuits, if there's an error in your circuit and you go to silicon and you fabricate that and discover it at that stage, it's very expensive to fix. So validation and verification of circuits is very, very important. And so Google invests a lot in this. One sub area is formal verification tools, which are part of validation tools for circuits. And that is one place where people with circuit design and logic backgrounds do work in Google.
Great. Our next question comes from Shen, and it is there a group doing research on compiler or program analysis?
Oh, yes, absolutely. So thank you for asking that. That's the area in which I did my PhD. And even though I'm in a security group here, I have a soft spot for that. Google has a concept of 20% time where you can get buy-in from your manager and work on some other project. And I have always used my 20% time and always used it for compilers and program analysis related projects. So there is a lot of work happening. There is, for example, compilation work within Android. There is compilation work within the Chrome team. There's work on virtual machines. Google also contributes heavily to the LLVM project. You can just, this is an open source project, and you can look upstream and you will see that there are commits from Google engineers happening all the time. I gave one example of a testing tool for security software, but we also have a lot of both internal and external infrastructure. So if you look at the terms MSAN, which is MSAN, which is memory sanitizer, TSAN, thread sanitizer. These are also open source projects for finding memory and concurrency bugs, which involve knowledge of program analysis. And yeah, so there's a very wide range of things there. Please apply.
All right, great. Our next question is from Taha, and it is, what does an industry mentor do? I know that you mentioned that you were an industry mentor for a couple of students.
Right. So I have been an industry mentor in two different capacities. So I have two students, and they speak to different things that I do. In one case, the student was working on analysis of concurrent programs, or is actually, and wanted my input because I had expertise on logic-based techniques. So I was providing that kind of expertise there. And in the so that was more informal. It is not explicitly through Google or anything. It's just that my manager is fine with that. In another case, there was a person who received a Google fellowship, and then as part of this, they can, if they want, have an industry mentor. And what I did there was the person then came here for an internship. I hosted them. We worked together, and so there I participate in their development as an engineer. But also during their PhD, when sometimes they have implementation choices or they are wondering what systems to contribute to, then I might be able to point out, well, here are some open source projects that we also contribute to, and I might be able to run experiments for you at some stage if you want to write a paper and so on. So all of these are activities that I can participate in as an industry mentor.
Great. Our next question is from David. Are there positions at Google that are closer to the academic blue sky research that you can talk about?
So I am not entirely sure what academic blue sky here means, because we do have long-term projects. So already safe browsing was one example. It is definitely applied, but something it shares with some academic projects is it's been running for more than 7 years. I know that there are people with PhDs in, say, mathematics and fundamental sciences, and we do have life sciences teams that do research in those areas. Within computer science, I'm not entirely sure, and I should confess ignorance here. I know that there are people who have done things like post-quantum cryptography research, which I believe are not about producing production systems, because we don't have production level quantum computers yet. So that is an example of something I would consider blue sky academic research. But as a rule, that's not what people in general, even people with PhDs, do on a daily basis.
Next question. Could you tell us more about why you decided to consider coming to Google and what factors and considerations led you here?
Right. So a lot of it was about personal happiness and personal effectiveness. So I try to say, well, what configuration of my day-to-day life allows me to maximize my research output, engage my brain in ways that keep me happy and productive and able to contribute to the community, or the kind of sea of knowledge that I would like to give back to, but also keep me happy in the process. So something that really bothered me is there were some topics that I like to work on at the intersection of logic and algebra, which weren't very fashionable, and it was very difficult to publish there. And so I wanted to not have the kind of research that I did be necessarily tied to my ability to put food on my table, right? So I wanted to decouple these two, and I found that very liberating after coming here, that there is work I do and I enjoy doing and I get paid for, and I can set time aside to do any kind of research, any kind of absolutely fundamental or esoteric research that I want. And I can also do more applied research as part of my regular job. So that was a very big factor for me. The other factor is that I was a researcher in programming languages, and often we would write abstracts or introductions saying, well, these are the kind of problems engineers face in industry. And I felt, I need to find out if these are really the problems that engineers face, and I want to go out there into the field, in the wild, and be an engineer for a while and see what it's like. So I didn't come here thinking I would stay here for as long as I have. I came here mainly to be a sort of alien visitor and be able to go back and write in my papers like, well, I have seen the truth and you should listen to me. But I was happy enough and able to do the things I wanted to here that I continued and stayed.
Well, we're really glad you're an alien visitor here. Just a couple more questions. What are some of the biggest challenges your team expects to face over the next couple of years?
So Google is investing in a large way in everything related to the cloud. I'm in a team that is concerned with security and privacy and developing tools for security and privacy. So, a challenge that we always have at the back of our minds is what are security and privacy issues related to cloud-based services? And that's the sort of big picture thing that we're thinking about now. And the other thing that is inescapable if you've listened to any technical messaging from Google is machine learning. So Google invests a lot in machine learning, produces a lot of machine learning infrastructure, and we are also constantly looking for ways in which we can make systems more secure and safe using our machine learning technology.
And then the last question, I know you mentioned this in some of your earlier slides about how freedom can be complex, but how much freedom do you have in choosing the direction of your work?
So typically what happens is our organization is working on certain projects, has expertise on certain projects, and so we will work in that area. And there are certain needs that come to us from more senior leadership, but I have found that, and I'm usually, at least my inclination is I'm happy to work on anything. I have been able to find research level scope in whatever problem has been given to me. And nobody has told me how to solve a problem. I've been usually told, well, here's a problem that we need to solve. And I usually have flexibility in choosing the exact way in which I solve the problem. This applies to projects where you largely start maybe from the ground up or only a little bit of infrastructure exists. Sometimes a project has been running for a long time, in which case you can't just burn everything to the ground and start from scratch. And there are many more constraints, especially depending on what infrastructure has been used and who's using that kind of project. And that's just part of the job. I look at it that way.
Great. Well, thank you so much. Thank all of you for watching, and a huge thank you to Vijay, our wonderful speaker. One last reminder, if you are interested in opportunities here at Google, the software engineering internship application for PhDs closes January 31st, and we do have full-time software engineering roles available for PhDs. All of these roles and all of our other roles can be found at google.com/students. Thanks again for watching, and we hope to see you on campus very soon. Bye.
Bye.